Thank you so much to our lightning speakers. This is a really great way to tee up what we're now going to segue into here, this panel on the future of exposure mapping. We've heard about weather, we've heard about floods, we've heard about permafrost. Now we have an opportunity to hear from 3 experts, very diverse perspectives on the future of exposure mapping techniques. So please join me in welcoming our esteemed panel. Thank you so much for joining us. And I think what we're going to do is, each of you, I think, have prepared a short presentation. So I do not know who is going first. James, who's up first? Okay. We are going to first welcome Dr. Michael.
Mr. Michael.
Sorry. Mr. Michael Koterba, Chief Technology Officer from NJ Engineering. We're really looking forward to hearing what you have to offer us on the future of exposure mapping.
Thank you, everyone. Thank you for inviting us here today. I'll give you a little backstory. MJ Engineering and Land Surveying is a multidisciplined civil engineering land surveying firm located within all various offices throughout New York State. And we're often the first boots on the ground in response to disasters or natural, man-made. We're often the first in a flooded subway tunnel or the first to respond when a roadway washes out. And we are there to collect data, design improvements, and mitigate some of these disasters. So in accomplishing that, what we've done for a number of years now is build a digital twin. And the idea there is we're on the ground, we're collecting all this rich data sets, and what do you do with it? A lot of times what we'll do is use it to generate simple mapping deliverables, and then the data gets stale, it sits on a shelf, and isn't as useful as it could be. So we've been struggling for probably the last 20 years since we bought our first LiDAR system. How do we make this data, how do we increase the amount of value that this data has, both to us internally and to our external clients? So what we strive to do is develop a digital twin with this data. And it can be utilized across a wide range of applications, from your design engineer to your plant manager, and then for planning studies, So, and what do we input into these data sets is a variety of geospatial tools and software. And a typical digital twin will contain features such as Street View LiDAR, so whether it's acquired from a mobile platform, a mobile phone, all of these can be inputted and viewed within this platform. So you'll have your horizontal assets, you'll have your utility infrastructure, whether it be manholes, valves, power lines, all that can be contained and viewed within the same platform. A lot of our projects involve inventorying traffic signs for pedestrian safety improvements. And then you can also include access to existing record plans. So any data external to your collection can also be geo-referenced and utilized in the same interface. So why do this? Is giving everyone involved in a project access to this same level of data. No longer is a user required to have advanced software to do this. Most of this data can be accessed either from a mobile device or other features through a desktop computer. So you're democratizing access to this data. It's not just used by the design engineers. And what that allows is for a variety of different parties to access that same rich and accurate data and make better decisions using it. The design process is simplified when everyone's looking at a virtual representation of the same data set. You're not just inferring things about a site from plans. You can actually walk and measure yourself. And the big plus of this is actually to document infrastructure as it's being constructed. So the idea is, as new utilities, as buildings go up, you'll go through and capture things at different stages of construction. So you have that time component. And the need for such an ability became very apparent, obviously, during the pandemic, where people still needed to work on these large projects, but couldn't physically access a lot of these sites. So being able to have the team go and fully capture and be able to present it to people in distributed teams was a huge value. And also, a lot of these spaces we document aren't accessible. So sometimes our equipment needs to go into confined spaces or things like that, and the equipment can go and the operators can stay out, and then everyone can have access to that same data set. And same thing with scheduling. Sometimes you have very limited access to a site, and you can get in and out very quickly using these tools. So there's asset management applications to this technology to document a site. Also, we utilize it a lot within monitoring, planned preventative maintenance, and you can visualize planned construction. So if you want to see how something's going to look within a space, you can render that. So what are the reality capture tools that we use? At MJ, we are a Trimble partner. We utilize Trimble equipment for both acquiring mobile LiDAR and imagery. The tools listed there run from mobile LiDAR that goes to a vehicle, to wearable LiDAR, multi-beam echo sounders, UAVs equipped with either photogrammetric sensors or LiDAR, your traditional terrestrial static laser scanning, UAV-based LiDAR. We've got an autonomous that can perform static scans. And then you've got your traditional just single data point collection routines, which involve single GPS units. So all the data that's collected from this different equipment can all be consolidated into a single point, can be visualized and utilized very easily now. Down the road, the next level tools, obviously, we've got great LiDAR, we've got great imagery, and what's really gonna help give us that extra layer of insight with this data are these next-gen tools, AI-enhanced LiDAR, improvements in hyperspectral imaging, GPR being refined so that things are clearer. Quantum LiDAR sensors are gonna give us another definition there, as well as radar interferometry sensors and synthetic aperture radar. So these enhanced sensors are gonna be able to be integrated with this digital twin and give everyone enhanced access and insight. So, thank you all.
Thank you so much. I appreciate this perspective, thinking about how we can collect more data in a process towards like democratization of data and what the future of reality capture looks like. This is really exciting. Next, we're going to have, I think, David Carttar, the Senior Director from Geospatial Development from Moody's, give us his perspective on the future of exposure mapping techniques. Thanks so much.
Thanks very much. So first, to start, just a couple of words about what I do, the company that I work for. Moody's RMS is primarily a modeling company. We model catastrophic risk. And so I'm going to be talking about exposure from the standpoint of a company that services largely the insurance industry. So our clients are insurance companies, and their clients are all of us. Basically, any of us who need to be able to insure our property. And so that's the lens that I'm going to be looking at this through. So in order to keep this to a time limit, I'm going to be talking in four basic categories. I want to talk about location, that is geocoding, which I think is something that those of us in the geospatial profession tend to overlook. We look at big problems, but one of the things that we can easily overlook is how do you get from real-world properties, real-world singularities into the massive databases that need to be analyzed. I'm going to talk a little bit about attribution, about the role of exposure in defining risk, and then finally talk about some of what I think are burning questions. Okay. So in locating exposure, from our perspective, the objective is to locate a specific property. Exposure, from our client's perspective, isn't an abstraction. It's not just a huge data set. It is a data set made up of individual clients with individual properties. So in order to get a reliable answer, we've got to have reliable inputs. So the first step is to interpret each address completely and accurately. We need to be able to understand what the components of an address, how they function, and how they match to geographic data elements, so that we can accurately locate the property. So we may think we know what an address looks like. From a U.S. or Western perspective, we've got a building number, we've got a street name and type, we've got a town, we may have an administrative division, we might have a postal code. The thing is, in different parts of the world, those same components take on a different configuration. And so that morphology begins to break down the further we get from what we're familiar with. And so our models need to be able to recognize all of those components at scale, because we're talking typically about millions, tens of millions, hundreds of millions of locations at a time. Once we've been able to do that, we need to be able to match each of those components with some element in a base map, and then prioritize those so we can figure out which one of those is the most precise. So we may be able to match a street name. We may be able to match an address range along that street, or maybe an individual parcel, maybe the centroid of a building. But we need to be able to figure out which of those are we recognizing at any given time. What if we can recognize the address range, the parcel, the building centroid, and even a point of interest, basically a business name. We need to be able to prioritize which of those we have the most confidence in, so we can say, yeah, that is my answer. That is the latitude, longitude coordinate that I want to return and enter into property number 150 out of 10 million in my analysis. So once that's complete, we need to understand not just where something is, but what it is. So going back decades, looking at large numbers of properties at a time, we look at being able to use remote sensing to identify gross characteristics like the age of a building. Was it there in a particular image capture versus a more current capture? We can use photogrammetry to understand the height. We can understand the shape and orientation, which are extremely important in understanding the damageability from certain types of risk like earthquake or wind. We can look at the roof type, which can help us understand the vulnerability especially to wind and puncturing the building envelope. We can use cadastral records to recognize the address, who owns the property, how much it's worth. If we have access to insurance records, we can understand the primary and secondary construction characteristics. What is it largely made of, and does it have the various adaptations that are going to be needed to make it especially resistant to certain types of external forces? If we have business records, we can understand the firm name, the contacts in case of an emergency or to model business interruption. What is the line of business? Is this building an office or is it a store? Are perishables stored there? And then if we have access to commercial sources, we can understand what are the revenues, what is the business loss at risk, and then increasingly, data providers are also service providers. So, for example, TomTom, a major global data provider, is also a GPS company. And so they collect real-time feedback from their users in case a particular location is represented incorrectly in their data set. So we can increasingly update these data sets in real time. So there was a time when storage was the big challenge for high precision exposure data sets. Increasingly, that's not the problem, but I see one of the biggest challenges, this inverse relationship between precision and stability. So if we're trying to offer reliable answers to questions, how do we know that a particular high-value business that we're modeling, high-value property that we're modeling, didn't change its function yesterday? And the consequences of incorrect information can be really significant. When I started my career, 25, 30 years ago, I used this example. I stopped using it for a long time, but I think it's very significant again. This was from the NATO military campaign against Serbia in 1999, when the U.S. seemingly inexplicably bombed the Chinese embassy in Belgrade. There were lots of explanations that floated around, but one was they got the right building, but they thought it was part of the Serbian defense ministry. So you can have high precision, high accuracy, but if your attribution is mistaken, there can be huge consequences. So moving on to exposure's role in defining risk, and forgive me if I'm talking basics. For some of you, this is just obvious, but I think when I was starting my career in this business, this was an important distinction to make. We typically, in our line of work, talk about hazards. They're basically these forces in the world that are acting based on phenomena that are indifferent to human activity. Things like earthquakes, hurricanes, and floods, right? And they become risk once human activity is involved. It's basically the hazard intersecting with the built environment, and that is exposure. So again, it's kind of a tautology, but exposure is property that is exposed to a hazard, and risk is a hazard that acts on exposure, right? So if we look at New York City, that's exposure. We look at 1% or 0.2% annual flood risk, that's hazard, and the intersection of those are risk. And if we look at the modeled maximum flood extent in the year 2100, that is hazard acting on exposure, which defines risk. This, a product of the New York City Flood Hazard Mapper. Reevaluating this image, I was reflecting on a lot of the perspectives that were raised yesterday about risk being inequitably expressed. In this case, we see, Upper Manhattan at particular risk, and I imagine this is something we'll probably be exploring later in the day. But and I was really intrigued by Roger's description of emerging risk management vehicles. Being able to manage the risk of properties that may not be seen as particularly profitable from an insurance standpoint, that is going to be a challenge moving forward. So some of the burning issues that are on my mind almost all the time. There's, verifying what is where. I don't just need to know that something is there. I can see that from an image, but what is it? That's hugely important. Keeping the data current is important. Maintaining data integrity along networks of exchange. What I mean by that is, within the risk management industry, you as an insurance policy holder submit your location information to your insurance company, who combines that with their entire portfolio of risk. They pass it on to a reinsurer, and so and that may pass through a broker. Increasingly, location information changes hands. It goes from one data dictionary or one data schema into another, and has the potential to be disrupted, especially when you have international risk management and these address schemas, which may be different from place to place. Dealing with some hourly employee who needs to figure out how to get an address from Singapore to match an address from Switzerland, you increasingly run the risk of corruption. And it's really interesting to hear the presentations of people talking about other types of exposure, those that may not even have an address. In developing countries, largely, properties don't even have an address. It's basically through social networks that locations can be, that properties can be located. modeling and geocoding linear exposures, lifelines like gas and electric and road networks. Modeling and geocoding exposures that are constantly in motion, cargo. Basically, if we look back at the huge disruption to the global economy through the pandemic, it was basically subject to property, that is exposure, that could not be reliably located at critical times. And then finally, building from that, modeling relationships between properties. If we want to understand the complex profile of risk at any given time, we will need to be able to locate and quantify each of these types of exposure and understand their relationships. And I think those are the kinds of challenges we're going to be facing. So thank you very much.
Thank you so much for that perspective. I really appreciated one thing that you said, this idea that exposure is not an abstraction, right? So as we're thinking about all these other dimensions that we've talked about so far, this conference, we really need to be thinking about, whose exposure. I really appreciate that. I'm thrilled to be able to introduce Dr. Eric Tate, who's also going to offer his perspective about the future of exposure mapping techniques. Thank you so much for joining us.
All right, so that was a nice introduction. So the previous discussion was about sort of properties at risk, and he touched upon hazards. I'm going to talk about sort of exposure in terms of who is exposed, with a specific focus on floods. So my name's Eric Tate, and I'm a professor in the School of Public and International Affairs at Princeton University, and I'm a geographer. And I want to start by talking about what the current understanding of exposure is when we're talking about who. And essentially there's particularly over the last 5 years or so, there's been a growing understanding of disparities. A lot of it has been pushed forward through studies after major flood disasters, particularly hurricanes Katrina, Sandy, and Harvey, that had a large amount of studies attached to them. And now we know, right, that there are persistent social inequities when it comes to who's exposed to floods, who experiences the worst disaster impacts. And these are population groups, from people living in poverty to those living with disability, households who are renters, populated by racial and ethnic minorities at extremes of age, people that are linguistically isolated for a number of reasons. And this applies to all stages of disaster where we have these sort of impacts. Now, from a geographer's perspective, I think geographers have looked at this from two different directions. One is thinking about disasters as interactions of people in the environment, okay? And I would say, like, traditionally, the focus has been, well, we have a hazard, and it causes issues to stuff. This is how we think about physical assets. And people have extended that to think about people. But there's a sort of a counter view, is essentially that the human vulnerability is already there, and sometimes actually causes the disaster itself. So you can think about societal choices and where we live and how we develop, okay, can make a flood much worse. And so a lot of people, especially more recently, have been starting to really challenge this idea of a natural disaster, right? There's even like a Twitter hashtag and a sort of a media campaign to stop trying to get people to think about using that term because disasters aren't natural. This isn't new in geography. There's a paper here in 1976 taking the naturalness out of natural disasters is making this point. The other perspective that geographers use, I think, is through spatial analysis. And so in recent years, there's been a lot of mapping of indicators, social indicators, and social vulnerability indices. This one in the bottom right is showing sort of bivariate mapping. So now we can introduce multiple dimensions, the hazard and the people. There's been other examinations using the top right, sort of spatial clustering techniques, so we can understand sort of the spatial distributions of of spatial associations, and a lot of work using advanced linear regression techniques that account for spatial dependence. We can better identify who. I would say sort of the emergent areas in understanding who's exposed have to do with increasing complexity around compounding hazards. So I was just on a thesis defense a few months ago where the student was looking at the effects of landslides in California, and these landslides were precipitated by a big rainfall event that destabilized the soil, but the soil was so destabilized because of severe wildfire. So we have these hazard cascades that are not even coincident in time that can have outsized effects. And we're seeing other stuff with hurricanes having more rainfall and more increased pluvial flooding. So climate change is really affecting sort of these compounding hazards. And the other sort of intersectional characteristics of social vulnerability, it's not just whether you're poor or whether you're a renter, but poor renters may have distinct outcomes, okay? So great, we know that there's disparities, and we have an understanding of how to map and model these. So why are these happening? We've also increased understanding of this as well, and a lot of this has to do with our institutions. And so here I mean sort of not just organizations, but our practices and our policies and our norms that actually have a spatial imprint. So there's been a lot of talk about, for example, redlining over the last 5 years, right? We have this government policy that comes into place in the 1930s. The US government wants to make sure, as they're building up this new idea of this 30-year fixed mortgage, the government's gonna back them. We need to make sure that the government's not investing in risky areas. Defined risky areas by populations, right? Poor, black, et cetera. And so they made maps. So we have these redlining maps. The policy became a spatial footprint, but then it was attached with a whole bunch of other public policies around exclusionary zoning, cities incorporating and keeping other people out, urban renewal programs. They're associated with private programs to the real estate industry, steering people from place to place, blockbusting, using fear to keep people, to make people want to move and then they can sell their homes. And then sort of interactions between these public and private processes, things like restrictive covenants. So developers would put these rules on who could live in a particular subdivision. And so a lot of this, especially over the last 5 years, is through work in the digital humanities, have taken historical projects, historical data, often qualitative, archival, and made this into geospatial form. And now we can interact that information with other typical quantitative data. And so that's been changing. So you take all this historical discrimination, and then we wonder why we have these disparities. We're seeing this, right? And so other programs like in disaster assistance with the FEMA programs and HUD programs and the Small Business Administration that are giving out loans, but then certain places have lower credit scores so they can't get them, right? This is an effective housing programs. Other programs really favor homeowners over renters. So higher ownership rates benefit, but these are lower in many of these areas because of these historical processes. So we're getting a better understanding of how our policy choices actually have a physical spatial manifestation. One more that's getting a lot of attention lately is, and that's indicated like in this top one, social justice implications of managed retreat buyout programs. This paper really focused on the effect of benefit cost analyses that are, we would think that they're objectively neutral, but then they also favor really higher asset values. So we can see like just these historical processes have these really long-standing, persistent negative effects. So Meredith encouraged us to think big, right? And so what I would like to see is great. We understand how bad the problems are, and we're mapping these problems. Well, how about mapping solutions? Okay. There's a lot of focus on climate adaptation. I don't know if you saw this week, the 5th National Climate Assessment was released by the U.S. Global Change Research Program. And I had the privilege of serving on the author team for the climate adaptation chapter. And each of these chapters, they have several key messages. And I think in mapping solutions, we can get a better understanding of what's working and where it's working. So maybe we get an understanding of what's happening in New York, and maybe that can apply to something they want to do in Chicago, and people can learn from this. We need to capture the effectiveness of adaptation investments. And that was one of the key messages from our chapter. Actually, here's the title of that, key message 5, or key message 6. Adaptation investments and financing are difficult to track and maybe inadequate. So we're going to need new methods that bring in sort of quant and qual data and map these over space, right? And geographers can contribute to this. Other key messages from this chapter talk about centering equity in addressing inequitable exposure, thinking about transformational approaches rather than incremental as we're adapting. And we see the beginnings of sort of centering equity in some major federal programs. FEMA has the BRIC program and the FMA program, and they're sort of ingesting inequity data into their funding structures. CEDARS, this new Disaster Resilience Zone Act, is trying to prioritize government funding and sort of, amplify private sector funding based on vulnerability, which includes a social dimension. So to put it all together, I think moving forward, thinking about exposure beyond the physical to include people, as we go for solutions, let's try and map and model these. Let's think more multidimensionally, sort of the co-benefits of solutions. Okay, I'm gonna stop there. Thank you.
Wow, thank you so much. What a privilege to be able to hear these perspectives. You know, we've talked a lot about social justice, the inclusion of different perspectives, and the three of you have really helped to provoke thinking about the future of exposure mapping techniques. Does anybody have any questions that they want to offer to these amazing panelists? If you are interested, we have 2 microphones kind of in the center of the room. I welcome you to come up here. And while I'm waiting for the audience, I might come back to the 3 of you, and I really appreciate how you offered some blue sky ideas, and I really appreciate this. I might ask you, what keeps you up at night as you think about the future of these exposure mapping techniques? Thinking about adaptation as being solution oriented, thinking about exposure not being an abstraction, thinking about the fact that so much data can be spatialized to inform decision making. I want to have time for the audience, but maybe briefly you can just say, from your perspective, what keeps you up at night thinking about the future? Eric, do you want to start us off?
Yeah, I think what worries me is that even with all this attention to the human dimensions of problems, if this is going to be a sort of a permanent change or something that's ephemeral. And if we don't get it right now, we could be get on paths that are set in stone that may perpetuate inequities. So it's an opportunity right now, but it's sort of urgent and we need to get it right.
Urgent optimism, impatient optimism.
I guess from my perspective, not that I speak from experience, getting it wrong.
Yeah.
Because as I said earlier, what we do is not an abstraction. It's not a purely academic exercise. It has actual consequences, and to get the wrong answer literally does keep you up at night because you have very unhappy. You have unhappy clients who have made decisions based on the answers you've given them, and when folks are losing money or lives are affected. And the chain of responsibility narrows. Yeah, that's not a good thing.
Thanks for that.
Yeah, on our end, what keeps me up at night is how much work there is to do with so few resources to do it all. So how do we accomplish more with less? And we have to work more intelligently. We got to work with all the tools in the toolbox more efficiently to do more with less.
Yeah, these are Thank you for sharing that. I appreciate your perspectives. I think we have one question from the audience. Hi.
Yeah, hi. This is Al Leidner from New York City Gizmo. My question is, you're very concerned about exposure, and not only locally, nationally, internationally, and needing a paradigm to be able to assess things around the world. And I'm wondering where data standards come in. Because if all the data is being built to a common standard, and those standards reflect the kinds of analytics that would drive analytics so that you could get a consistent answer around the world or around the nation, that would be for the good. And I haven't heard about let's drive standards so they really meet our data needs.
I love that. This is like data for decision making and then decision making for data. Maybe Eric, you can take a stab at this given your role.
I agree. So, for example, in trying to map inequities, we're increasingly using like building footprint data, right? And so the quality and many of these data sets are being pushed together now, right? So having common standards and levels of quality and understanding where the gaps are, because if you don't understand that, your answer may change, right? And now if you're making a policy decision on that, now the stakes have risen. So 100% agree with the importance of data standards.
Do you see data standards in your own work as you move forward?
Absolutely. As I mentioned, I was talking about addresses, right? We need to be able to have a morphology. We need to be able to have a typology by which to recognize every component so that we can be as broad as possible. In terms of purely structural components of exposure, obviously, the way a structure is built in Chile may be different from the way it's built in New York. And so we need to be able to have standards to be able to describe those characteristics so that we can analyze them in a consistent way.
And as far as we're concerned, inputting different data sets, having everything following a certain set standards, and a big helpful impact is, as projects get built, standardizing what's the final record, keeping that in a digital format that can be accessed and interpreted by a variety of platforms is what we're looking forward to.
I'll just add that one thing that Eric said inspired me, this idea that sort of geographers are really well placed to sort of be part of this conversation, right? Geographers can inform the process of data standards, the actually derivation of data standards, and also then the implementation of data standards. I think, did you have a question over here?
Oh,
Please.
I just wanted to say thank you very much, and just a little plug for the Open Geospatial Consortium,
Yes, totally.
which is trying to integrate all this data to common standards.
Awesome. Thank you.
Hi, all. Thanks for your presentations. I'm Katie Can from Rutgers University. My question's prompted by Dr. Tate's presentation, but I suppose it's appropriate for all the panelists. I'm interested in this idea of identifying co-benefits of adaptation projects. I think that's something I'm thinking about a lot, especially as we're kind of struggling, I think, in the discipline to also identify what effective adaptation really looks like. So I was wondering if you had kind of ideas for the future, the discipline, and how methods that we can kind of engage with communities to better understand what effective adaptation looks like for them, and also what effective adaptation looks like for funding organizations who are kind of leading those developments.
Yeah, so your question is about sort of methods, and I'm gonna go a little bit higher, and I think we still need to fully embrace sort of a paradigm shift. So one of the key messages from our adaptation chapter was the need to center equity. And by doing that, that means you're including people from the beginning, you're using equity as a sort of a organizational principle, and when you start doing that, you automatically start thinking about what are the barriers to adaptation and for who, right? And I think by just having that thought process, then the methods for how you get there will become more clear. But what I am seeing instead is that people are seeing sort of data that can represent social dimensions. They get a number and then they just go with it and not really understand what's happening. So we need to advance beyond, hey, we can model and map this, to what is actually happening, and then centering that in decision-making processes. And I think the path will be more clear after that.
Michael, how does that factor into like the data that you actually collect? right? Because you're actually on the ground with those cool, like, mechanical dogs and stuff like that, right? So you collect this data, and then David, you like analyze it, right? Like, how does this? I don't know. I mean, like, when you're talking about co-design, are there implications for your efforts here?
I definitely feel that when you can get this data exposed to people at all different levels involved with this project, that everyone's going to be able to kind of leverage it differently in different ways. And the biggest thing is just getting it out there and people using it.
Yeah. We have another question.
Hi, thanks, Meredith. As all this data is getting much more detailed, fine-grained, granular, how is that changing your workforce and the requirements of your engineers or your staff? Any thoughts, particularly with the teachers in the room, about how to think about how is this industry shifting and what are the skills that people are going to need to be productive in your worlds? Thank you.
On our end, I think it just helps for everyone to understand what data is already out there. When you start these projects, you're not starting from scratch anymore. You have 100 years of valuable geospatial data for a site already. And even if you don't use that to develop your say engineering deliverables, you need to leverage the insight of that as a quality control check on whatever you produce. So I think everyone just needs to know what's out there, how you can access it, and how you need to use that in addition to whatever new work you're doing.
I think from our end, forgive the cliche of doing more with less, but I think about the team that I've worked with for more than 20 years. I don't think it's gotten bigger, but our capacity has dramatically improved. Through automation and upscaling of skills, we're using a lot more automation. We are taking lessons learned and incorporating those into our quality assurance practices, and just trying to make sure that everything we fix doesn't break something else.
Totally.
Yeah, I think about this a lot. I've just been hiring a couple postdocs, and what I realize is that the students that I recruit, with their skills, what I need from them have fundamentally changed over the last 5 years.
Totally.
It's no longer enough for people to understand how vulnerability works, for example. I need people that can handle data, that can code, that can geoprocess, that can optimize. We need efficiency given the size of these data sets. And so these are the kinds of skills, in addition to the thematic understanding, that I think are going to be increasingly required going forward.
So we're at time now, and I would just like to say thank you to the three of you, and also to our lightning presenters for offering such a provocative way to start the day. Maybe in one or two words, I don't mean to put you on the spot, how does geography make you optimistic for the future of exposure mapping techniques? What makes you, like, one or two words? And then John's going to make us go. Are you optimistic?
I'd say yes, because geographers are generalists and experts at incorporating new information.
Awesome. Thank you.
Unique perspective.
Thank you.
Leverage everything you can.
Awesome. Thank you so much for your time.